Hello, my name is Pamela Cuther, and I am an instructional specialist for secondary mathematics with Richmond Public Schools. Welcome to the Richmond Public Schools Distance Learning Modules. In this series, we will learn Algebra 1, where we will have a different focus each week. This week's focus is SOL A.4a, Evaluating Expressions. Today we will review term, like terms, and combining like terms. Before we get started, you will need a few supplies: your interactive notebook or a few sheets of paper, pencil or other writing utensil, and you will need the Desmos calculator. Here are the answers to yesterday's practice problems. Please take some time to check your answers and make any corrections. First, we will start with problem number 1. Problem number 1 is negative cube root of a minus b squared plus c. The values are a equals negative 8, b equals negative 1/2, and c equals ab. We first need to solve for c to establish what that value will be. So I'm going to start by plugging in the values for a and b. Negative 8 times negative 1/2. And that's going to give us c equals 4. So that's our value for c. So now I'm going to plug in my values for a, b, and c into our given expression. Notice that I put the negative numbers in parentheses so that I don't make any errors. So now I'll start simplifying. I'm going to have the negative cube root of negative 8, and the cube root of negative 8 is negative 2. I'm going to square negative 1/2, which is going to give me 1/4, and then I just bring down the 4. We know a negative times a negative is a positive, so a negative 2 is really just positive 2. And then I'm going to bring down the minus 1/4 plus 4. Now, because I'm working by hand, I need to get a common denominator. Remember, you can put this into the Desmos calculator. Once you plug in the values, you can put that straight into the Desmos calculator. So my common denominator will be fourths. So I have 8/4, which is equivalent to 2. 1/4, I just brought that down. And then 16/4, which is equivalent to 4. Now I'm going to hold on to my denominator, which is 4, and combine the numerators. 8 minus 1 is 7, and 7 plus 16 is 23. And that is my answer. I can also write my answer as a mixed number. 23 divided by 4 is going to give me 5 3/4. And that's my answer written as a mixed number. And I can lastly write my answer as a decimal. So 5 3/4 is the same as 5.75. Let's look at question number 2. Now, question number 2 has 4 expressions that we need to simplify, and we need to determine which of those 4 are equal to each other. So I'm going to first write down my values for my variables. A equals -4, B equals 1/2, and C equals 9. So I'm going to start with my first expression. They're not really numbered, but my first expression is A squared plus the absolute value of AB divided by C. So I'm going to substitute in my values. Notice I don't have anything that I need to do in my denominator, so at this point I'm just simplifying my numerator. So I'm going to square my -4 and get 16. And then inside the absolute value bars, I'm going to multiply those values. -4 times 1/2 is going to give me absolute value of -2. My next step is going to be to just find the absolute value of -2, and we know absolute value is always positive. So that's going to give me 2. Now I'm going to continue to simplify my numerator. 16 plus 2 is 18. 18 divided by 9. And then I'm going to just simplify that. 18 divided by 9 is 2. Let's look at the next expression. And remember, these are not numbered, so if you did them in a different order, just make sure you're looking at the expression so you're checking work for the right one. So this one is C times AB squared divided by 2C. So I'm going to substitute in my values. So notice I do have something to do. I have an operation in my denominator, so I do need to simplify that, but I'm going to simplify the numerator and denominator separately and then bring them together at the end, similar to what we did yesterday. So I'm going to go ahead and simplify my parentheses. -4 times 1/2 is -2. That's being squared. And then my denominator, 2 times 9 gives me 18. The -2 squared is 4. I'm going to multiply that times my 9 and get 36. And then I put that over the 18 that's in the denominator. 36 divided by 18 is 2. So now I know that these two expressions are equal. Their values are equal. So I'm going to go ahead and put a box around those because I know those are equivalent. Let's look at the next two. So the next expression is A squared minus B times the square root of C. I'm just going to write my values again. So I'm going to substitute in my values, and then I'm going to start simplifying here. So my -4 squared is 16, and the square root of 9 is 3. Then I'm going to multiply. Just going to bring down the 16 because I don't have to do anything with that right now. And 1/2 times 3 is 3/2. And now since I have a fraction again, I have to get a common denominator. Remember, if you want to put this in the decimals calculator, you can do that. As soon as you substitute in the values, you can go ahead and plug that whole expression into the decimals calculator, just like we discussed yesterday. So my common denominator would be 2. And so I'm trying to get an equivalent fraction for the whole number 16, and that would be 32/2. And now I'm going to hold on to my denominator just like I did in the previous problem and combine my numerators. So 32 minus 3 gives me 29/2, which I can, of course, rewrite as 14.5. We know that's not equal to the two expressions earlier, so I'm going to go ahead and just cross that one out. And let's look at the last one. So the last one says the cube root of a, b squared, c, all that's multiplication under the radical, minus ab. I was getting a little ahead of myself, writing the 1/4. So I'm going to plug in my values. Remember, it's important to put your numbers that you're squaring in parentheses, especially when it's so many numbers connected there, so that it'll stay clean. It won't get jumbled and confusing. So as I continue to simplify, I have -4 times 1/4 times 9. I'm going to multiply that from left to right. So -1/4 times 1/4, -4 times 1/4 is -1. And -1 times 9 is -9. Now I'm going to go to the second part here. -4 times 1/2 is minus -2. And we know a negative times a negative is a positive, or you can say subtracting a negative is addition, however you want to say that. Now this we know is going to be a decimal answer because the cube root of -9 is not an integer. And so we know because it's a decimal answer that it will not be equivalent to either of the other expressions. So I'm going to go ahead and cross that one out as well. So the first two expressions are the ones that are equal. And lastly, we're going to look at number 3. Make sure you check your work. We're just taking a little pause here so you can check your work and make any corrections. And then after that, we're going to look at number 3. And if you want to get a decimal answer for cube root of -9, that is equal to -2.08 if you want to write that down. The cube root of -9 is -2.08. And then we're going to look at the last problem, number 3. And that reads 3x times the absolute value of x cubed plus 7. 3x times the absolute value of x cubed plus 7. So I'm going to substitute in that -4. Notice how I continue to put parentheses around my negative numbers because I just want to make sure I don't do any errors when I'm computing. So as I am simplifying here, I'm working inside of my absolute value bars first. So I have negative 4 cubed, which is going to give me negative 64. And negative 64 plus 7 is going to give me negative 57. And my step after that would be to find the absolute value of negative 57, which we know the absolute value is positive. So it would be positive 57. Now I just need to simply multiply from left to right. And I can multiply those straight in a row, and I get negative 684. And those are the practice problems from the previous day's set. Before we learn our skill for today, we need to familiarize ourselves with a few vocabulary terms. Please copy the vocabulary term, illustrations, and definitions into your notebook. There is a definition link next to one of the terms. Please click on that to get the definition. We will pause to give you time to copy that information. Now we are ready to look at our instructional videos. There are 3, which will explain our skill for today. Before we start, please open the notes. Copy the notes and fill in the blanks for each of the videos. The videos are also linked in the presentation. After you're done watching the videos and completing the notes, please come back to this presentation. Now that you've learned our skills for today, we will look at some model examples. Please copy and complete the examples in your notebook. Feel free to copy down any additional information or helpful hints that you hear throughout the explanation. Our first example is negative 6k plus 7k. Remember, when we have terms that are alike, and these are alike because they have the same variable raised to the same exponent, that's one of your definitions. We only need to combine the coefficients. The coefficients are the numbers that are in front of the variable. So here we have negative 6k plus 7k. They are alike, so all I need to do is combine the coefficients. So I have negative 6 plus 7, which gives me 1k. Now remember that the 1 is understood to be in front of the variable, so normally when we write that answer, we would not write the 1, but we know that it's there. So the better answer, the more algebraic answer, would be just to write k. Let's look at the next example. N minus 10 plus 9n minus 3. So if you notice, I use my markers and some shapes to identify my like terms. I strongly suggest doing that. Even if you don't have markers, you can simply draw the boxes or the circles. Sometimes if you have 3, you might draw a triangle. Or you might draw a wavy line under there, but you need to draw some type of symbol to indicate which terms are alike. That'll help you stay grounded on which ones you want to combine. So here I have n, and then I have plus 9n. So that essentially means that I'm going to be adding 1n, because remember the 1 is understood to be there, plus 9n, which is going to give me 10n. I'm going to bring that into my final answer. Then I have negative 10. Now notice I said that is negative 10 because I read it first. I wouldn't say minus 10. I have to read it as negative 10. So that's going to give me negative 10 minus 3. Those are my constants. Remember, constants are terms that have no variables. So I have negative 10 minus 3, which gives me negative 13. So then when I want to bring those back together for one final answer, my final answer is going to be 10n minus 13. Remember, when you write your final answer, when you combine your like terms, the constants always go last. Let's look at a couple problems for you to try on your own. Remember to identify your like terms first, and then you're going to combine the coefficients. Make sure you pay close attention to the symbols in front of those terms. Give you a couple more seconds. All right, let's look at the solutions to these problems. Make sure you make any corrections to your work. If you need to had any errors and you need to make any corrections, please make those when we see the solutions. So here are the solutions. Let's go over those very quickly. So we have 4p plus 2p. Remember, those are alike because you have the same variable raised to the same exponent. So all you have to do is add the coefficients. So 4 plus 2 is 6. So you have 6p. The next one is n plus 4 minus 9 minus 5n. So again, I use my boxes and my circles. You can use colors if you like. Either way is fine. But I have n minus 5n, which again we said a variable without a number in front of it is understood to have a 1 there. So there are all variables have coefficients. If you don't see a number, it's a 1. So we have 1n minus 5n, which gives us negative 4n. Then I have 4. Notice I read that as 4 because it has a plus in front of it, so it's positive. So that's 4 minus 9, which is going to give us negative 5. So when I want to write that as a final answer, I have negative 4n minus 5. Remember, your constants go last, and you have to hold on to those signs. These answers look a little weird because we're used to getting just numerical answers, but here we're simplifying. We're not solving, we're simplifying. So we're going to get it into the simplest terms, and sometimes that means it's not nice and neat as a whole number or integer number. The next one is negative 5 plus 9n plus 6. So if you notice here, the only things I can combine are the negative 5 and the 6. The 9n doesn't have any other n terms to go with it. So I have negative 5 plus 6, which is going to give me 1. And the 9n, I just bring that down because I don't have anything else to go with it. But when I reorder my answer, remember the constant goes last, and so I have to rewrite that as 9n plus 1. And that concludes our lesson for today. During your remaining work time, please complete the practice problems and the online practice. The answers to the practice problems will be in tomorrow's module. Please enjoy the rest of your day and stay safe.